Just 100 years ago, few could boast that after coming in from the frost, they could warm their hands on a central heating radiator. Today, it's hard to imagine a modern city without these familiar heaters. But before reaching our homes, these products travel a long road from raw material to finished goods. Steel heating radiators are popular worldwide. Only 2 or 3 decades ago, interiors were adorned exclusively with cast iron models. So how are these indispensable elements of a heating system made? Today, steel radiators command the lion's share of the market, thanks to their excellent thermotechnical characteristics. Developed during the energy crisis, they meet all energy-saving requirements. They have low thermal inertia and are easy to control. Their quality is unquestionable. No wonder steel radiators are so popular. Historically, this plant inherits very old traditions. Since 1963, here in Karaganda, Kazakhstan, there has been the Teplopryba plant. The first heating radiators, back then cast iron, began to be produced in March 1963. During Perestroika, the company stopped making cast iron radiators, and in 2008 the Santehprom plant began restoring the tradition of manufacturing modern steel panel heating radiators in Kazakhstan, not cast iron, but new steel panel models. Keeping pace with the times, with the demands of history, ecology, and the green economy Kazakhstan pursues, we launched this unique line on Italian equipment to produce radiators that are environmentally friendly, safe, hygienic, and, most importantly, not only aesthetically pleasing, but offering much better heat output compared to cast iron radiators. The ever-popular steel radiators are arranged as follows. The heat carrier circulates inside 2 steel sheets with stamped recesses. These sheets are welded together, with 2 or 3 additional steel sheets attached that have a U-shaped imprint. That imprint creates air passages. On the rear side of the panel, there are U-shaped fins. They increase heat output by boosting the volume of warm air 2 to 3-fold. The entire assembly sits inside a decorative rectangular casing, tied together with side strips. Low-carbon corrosion-resistant steel is used for the panels. Future radiators arrive at the plant in coils. They're mounted on an auto-decoiler which feeds strip into the press. Under 450 tons of pressure, the radiator half panels are stamped. A radiator of type RS22 has 4 panels, that is, 2 full panels made from 4 half panels. The stamped half panel then goes to the radiator assembly section, where it's built into a panel. Heat-conducting rings are set into the panel, and multi-spot welding is performed with a fingertip electrode. Next, a convector, finned elements for higher temperature and better heat transfer, is welded to this half panel. The convectors are U-shaped steel fins welded to the inside of the panels. This is essentially the heating element where heat from the heat carrier, or a heating element, is transferred into the room. Next, the half panel is trimmed at the corners, and the radiator is assembled with transition tees on a butt welding machine. Assembly uses jigs. Welding runs automatically. The parts, half panels, 2 panels, and tees, are put together. and the fully assembled radiator is then ready for pressure testing and inspection. The radiator is then tested up to a working pressure of 1.3 MPa. In other words, it is pressure tested. If it fails, it's sent for rework, where all seams are additionally welded and the unit is retested. If it still shows poor results, it's deemed defective, though such cases are rare. After passing inspection, the unit is hung on a chain conveyor and carried into the degreasing chamber. Here, a special solution called Phosphotech is sprayed over the products at 90–120 degrees Celsius. The radiators are then dried at 80–90 degrees Celsius. One last step remains, painting the almost finished units. This is done manually with spray guns. After painting, the products go into the oven, where in 20 minutes at 190 degrees Celsius, the coating is cured, baked. Before packaging, laboratory tests are mandatory. I'm going to test the radiator now. These are acceptance tests. Here we check the paint and varnish coating. At this stage, I'll measure gloss and whiteness with a special device called a gloss meter. We take the gloss and whiteness readings. There are specific values we must meet. If something is out of spec, we inform the section. All the results are recorded in the log. For example, our whiteness right now is 76. This is a good result. We also measure coating thickness. This is crucial because a coating that's too thick can chip. Another required test is adhesion, the paint's bond to the metal. We make a crosshatch cut, apply adhesive tape, and peel it off. If no paint remains on the tape, everything is fine. The heating unit is ready. It only needs to be wrapped in shrink film and sent to the warehouse. A steel radiator has a great many advantages, and arguably not a single drawback. Such radiators are reliable, visually appealing, economical, and highly efficient. Their output and temperature can be regulated. They require only a small volume of heat carrier, yet deliver high heat transfer. So choose steel radiators, made in Kazakhstan.